All right, next recap is of linear momentum. We went over this a little bit, and it's pretty simple. Linear momentum is represented P equals m times v, mass times velocity. It's representing the tendency for an object to continue moving at whatever speed it's going at with whatever mass. And the biggest idea is that momentum is conserved, meaning this product is the same as before and after. So the main idea is just m1 v1 equals m2 v2. This is true unless we are exerting external force into the system or adding some external sort of energy or force into the system, in which case it's not conserved. But in these cases, it is conserved whether there is no external force. So that's all we really need to know going into problem number 9. Next up, problem 28. We have 3 different blocks. First one with a mass 1, second one with a mass 2, and the third one with a mass 3, A, B, and C. And block 1 has initial velocity v. And then basically, we're on a frictionless surface. Block 1 will hit block 2, and they will stick together, meaning it's a perfectly inelastic collision. And then they'll move at a certain velocity, and then at the end, it will hit block 3, and they will all stick together. So we have this one giant block of mass 6 moving at an unknown velocity. And they're asking us to find the velocity of block C at the end, which is going to be the same as the velocity of the whole big blob because they stick together. It's an inelastic collision, and the velocities are the same because they're the same object, basically. So this is just a classic conservation of momentum problem. The first initial momentum is 1. That's the mass. I guess it's 1m times v. So mv equals the mass of the big blob at the end is going to be 6m times question mark. That was what we're trying to find. And solving for question mark, we divide by m, divide by 6, we get v over 6 equals question mark. And that's the answer. Pretty simple conservation momentum problem. It's answer choice B.